Sweet. Okay, let's get started. I'm going to break up this conversation with force. All right. So today we're talking about epistemology and inference. Wow, an interesting topic. Who does this sound interesting to? I vote. Okay. No, good. I want like honest answers. Cool. So our icebreaker for today is what inferences have people made about you? What kind of assumptions or logical, maybe they did it explicitly logically, maybe they subconsciously did it logically, but they made some kind of inference about you, and then they acted upon it. Like maybe they told you something that you felt like aggressed upon, or maybe they like implied something to you based on this inference. Who wants to start? Yes.
I think I've been told that I seem intimidating at first until they realize I'm stupid and not like, yeah.
What is like the logical basis you think they made this inference with?
Well, for example, they noted specifically that I was wearing like hella fits and stuff, and then actually one of them thought I was a freaking mom because I had a purse on me.
Oh shit!
It was hilarious. And then like my hair was shorter, so it was like they were like that bitch energy, and I was the camera and stuff.
Interesting. So they were like, she has a purse. Mothers have purses. Therefore, she is a mother.
Yeah.
Okay.
Yeah.
Okay. Cool.
I'll need a second before.
Okay. Who else then next? I'm gonna call him Milo.
I think like consequential. I don't know. The other day, somebody asked me to
Right. I mean, that's still like an inference they made,
exactly.
right? What is like the basis of that inference, you think? Yes, indeed. Okay, cool. Who next, John?
The only thing that comes to mind, similar to Mellon, I guess, like, I used like from middle school, my high school. Like you can't see I'm Brazilian.
Yeah, no, that's what I was thinking of too.
But yeah, so we're like, oh, you're just like another American guy. I've been called like dumb white guy. You know, in high school, sure. But then like, yes, I'm very white, but actually, well, I guess
Yeah, like South America. Beast.
sometimes.
Yeah, I just thought I have one.
Yeah.
So when I'm home, like in India, and because of the way I dress and like I speak English and stuff, like people assume I don't know grammar. So like I remember once like I was on the way to like a temple, and this like guy behind me, he had a problem with me having my shoes on still, and he like said something really rude in Tamil. And like I looked back and I was like, I responded in Tamil, and then he like shut his mouth. But, like, yeah, like it happens quite often there. But in my defense, like I wasn't wearing inside the temple; it was like on the way. So.
So they were like, oh, she's like dressed like she'd speak English or something like that.
Yeah, she's dressed like she would speak.
Interesting. Okay, Anton.
I have a couple. One is that I've had people like whenever I would do 2 truths and a lie, I would always have one of my truths says I was born in Florida, because people never pick that. They always think that I'm born in India. Just I don't know. Yeah. So which I get, but unfortunately that's how I was born in that nefarious state. It's fine. And then the second thing is I've had people assume that I'm lesbian, or that I'm like not straight. I just have short hair, and I don't put a lot of thought into like what I wear on a daily basis. So I understand people getting that vibe. I mean, I guess it's a compliment because all my friends that are lesbian are really cool. But unfortunately, I am not that.
Yeah, no, I think there's a lot of kind of like subconscious, like we think of them as biases, but they're like they're in a sense logical deduction, right? Like a lot of lesbians have like short hair, or at least we perceive them to have short hair. So then people go about applying that like rule, that stereotype they have in other places. And we're gonna look at the structure of these logical fallacies today. But yeah, Chris.
Um, like, honestly, I think I'm really privileged. Like I haven't really been like this really friendly. I guess something really mundane. People just assume you have like an iPhone. Like if they see you wearing with a helmet, like they just assume it's an iPad and stuff. Like it's not like fancy. Like they don't even know that. Like a thing other than Apple.
Oh my God, you're so fast.
Yeah. Cool. Okay, and then what's your name?
Oh, Stella.
Stella. Okay, so Stella is auditing this course for Stuco Exec. So she's making sure that I'm like a good teacher and whatnot, right?
Yeah.
Okay. Do you want to answer the question?
Oh, I just similar to the first one that was said. I know some of my friends during the week, like they just thought I hated them because I guess that's kind of like a resting bitch face or whatever, where I'm not like very outwardly like happy all the time or whatever. So I had people tell me that they thought I hated them.
Cool. Yeah. I think, people, there's a lot of kind of extensions you can draw from just the way like people look at you, I guess. Like people like with social anxiety, I've heard like people they when other people just like look at them, they have like internal, they start like logically putting out assumptions about what they think other people are thinking about them. That Jason was telling me about this the other day. Yeah, really interesting stuff. So yeah, we're gonna look at these like overextensions of like logical arguments today, like where people apply logic where maybe it shouldn't be applied, right? Or people apply things that look like logic, right? Like these stereotypes about like lesbians or what like other people are thinking, or like resting bitch faces. We're gonna look at where these fallacies come from and like what the structure of a sound logical argument actually is. So like the first thing on this topic is like models of inference. So there's like a lot of these. Also we are before we move forward, we're gonna have our midterm assessment at the end of class today, which consists of you telling me what your proposal for the final project is going to be in like less than 30 seconds. Or so like it's like an idea proposal basically. Yeah, and then so just like be thinking about that over the course of the class today.
Do you decide on a delivery or just like the general idea?
Mainly the general topic. So that's like, mainly the general topic. You can also send it in to me after class if you want to write something more substantive. If you're sending it to me after class, like not face to face, then it's gonna be like a paragraph or two maybe, just because it's harder to get like a gist of what you're saying. It's like if like I can't ask you questions and like probe your thought, etc. Okay, cool. So models of inference. So there's a lot of sort of like spooky symbols up here, I guess. But the general idea is that like a model of inference is a function that takes us from premises to conclusions. So like the function up here is our model of inference. And there's tons of different models of inferences, right? I mean, like what are some inferential models you could think of? Like you might be taking classes on certain classes of inferential models. Is anyone here in machine learning or statistics? Has anyone in here taken a stats course? Okay. So can someone tell me some inferential models you might be aware of? Milo? Yeah, like linear regression, right? Exactly. So like if we have a bunch of points, right? Like this. And this is like the house price, the price of a house. And this is like the area. then we can be like, there seems to be a correlation here. So we can draw an inference about the data and say that there's a correlation between price and area, such that the higher the price of a house is, the more area it has. So that's like one inferential model, right? We can have these statistical models that allow us to perform inference. But what we're mainly going to be focusing on are logical or symbolic models of inference. So propositional logic is a pretty elementary kind of form of a logical model of inference. And over here we have a couple inferential rules that we can actually use in propositional logic. So the first one is modus ponens. Is anyone familiar with modus ponens? Yeah, Chris.
Yeah, it's like basically okay, so it like A then B, and then like it, well, yeah, it's like basically
Like, can you explain it sort of intuitively to people, I guess?
yeah, so yeah, it's like an argument method, like you want to establish something from like the premises and
Yeah, that's fine. I mean, like, yeah, the intuition I can be a bit complicated. Yeah,
like the symbolic basically means like you have something that's true and something else, and like when that is true, something else is true. If that first thing is true, then the second.
yeah, exactly. I think that's it's a complex way to put it. But like basically what this first modus ponens formula is saying is that if we know that P implies Q, and we also know P is true, then we can simply basically just like apply that rule, right? We can say, since we know P is true and P implies Q, then that means that Q is true through this implication rule that we know. So that's modus ponens. There's also modus tollens, which is sort of like a variant of that's sort of like contradiction. So modus ponens is actually surprisingly, you can apply it in like a ton of cases, and we'll basically the thing I'll say is that a lot of Indian approaches to logic, especially the specific form of inference called anumana, seems to follow this general structure of modus ponens. So this is the Nyaya model of inference. This is developed around 200 BC. And it's basically this list of 5 steps that you have to take in order to make a valid inference. So the first one is the hypothesis, right? So let's take, for example, the hypothesis that a mountain is fire possessing. And the reason we say this mountain is fire possessing is because it also possesses smoke. So we might not be able to see the fire. It's a hypothesis we're making, but we can see the smoke. We can observe that it possesses smoke. Then we need corroboration of the hetu, the reason. So whatever is smoke possessing is fire possessing. So like in a kitchen, for example, we see smoke, and we also see fire there. But in a lake, for example, we don't see smoke and we also don't see fire. So those sort of prove to us that this reason, this hetu, is actually a valid kind of connection that actually causally links smoke possession with fire possession. Then we have application. So this is basically the step where we take P and apply it. Sorry, we take P implies Q and we apply it to P. Right. So we take the fact that smoke implies fire, and then we apply it to our situation where we see that smoke has the fire, the mountain has the smoke, and then we infer, okay, that means that the mountain has the fire. And then finally we come to the conclusion, and we conclude, okay, the mountain has the smoke. One interesting thing is like step 3. The way it works in Indian philosophy is a lot more sort of like grounded in reality. You can't have a valid hetu unless you have a like true actual corroborations of the hetu. So you need actual examples that you provide. These examples are super important to the Indian logical structure. So you basically come up with, you have to have this like implication rule, P implies Q, as well as these witnesses to that implication. Cool. Any questions about this? Yeah, Chris.
So like, do these witnesses, like correlation things, have to be like on-tested or like observations of like kind of different examples that are still like
What do you mean by
Like,
theoretical?
so I was thinking about like, so I'm assuming this only applies in infinite planes, right? Or can it be like more like that? I really want to
I have not seen this explicitly be used for mathematical proofs. And proof theory in India actually isn't developed until about the 1300s with the Madhavas, like the Kerala school of mathematics. And even then, it's like nowhere near as developed as Western proof theory. But I mean, Western proof theory only really developed in the late 1800s as well. So, yeah, yeah, I haven't explicitly been seeing this used for mathematical proofs. Does that answer your question? Cool. Any other thoughts on this? Cool. Okay. Oh my God. All right, there we go. Okay, Vyapti. So am I on the right slide? I can't even tell. Okay, yeah, we are. All right, so bruh. Yeah, it's not even like, it's only when I'm sharing my screen, I think, or like when I'm putting it on HDMI, like it just starts acting up. All right, so Vyapti, right? So this is the actual pervasion relation. So they say that the sadhya, the fire, must be pervaded by the hetu, the smoke. So basically what this means is that wherever we have this universality rule, wherever we see the sadhya, wherever we see the fire, the hetu, wait. Sorry. For all, wait. Oh yeah, so I mean yeah, exactly. So for all sadhyas, if we observe the hetu, we must also be able to observe the sadhya. So that basically means like that's this universality rule over here. And we must prove this by both positive and negative examples. So I'm just like sort of formalizing with this universal syntax in that second bullet point. All like there must be this universality relation between them. And then so there's this other question where in Western approach to logic, you can have a valid argument that is still untrue. So for example, you can say Milo is wearing a red shirt. All people who wear red shirts also wear black shoes. Therefore, Milo is wearing black shoes. And let's imagine that I just didn't see the color of Milo's black shoes, and I just inferred it. That is a false, or that is a logically valid. That is a formally valid inference, right? That I had a proposition, I had a causal relation between wearing red shoes, or wearing a red shirt and wearing black shoes. And then I came to a conclusion that Milo is wearing black shoes. But the truth value is more blurry, right? Because Milo is wearing black shoes, but it's not true that all people who wear red shirts wear black shoes. So it's much more fuzzy when we get into these questions of formal validity versus truth in Western logic. Whereas in Indian approaches to logic, they basically say that there is no such thing as formal validity. You cannot be formally valid without being true. Because you need to have these witnesses to truth, right? One second. Like you need to have the positive example and the negative example, and if you don't have those, then you can't actually have a implication relation. And without that implication relation, you don't have a formally valid argument. Yeah.
Yeah, so it's from the notes, it's exactly.
This is like just like further elaboration on the specific nature of this, right? Of the implication. We need to have actual evidence of this implication, right? We need to be able to see the positive and the negative. And without those, we don't have a formally valid argument. So I guess in a way, like Indian logic is more entrenched in like empirical proofs, despite like common perceptions of people being like India is very like people have this perception that like India is very non-empirical, like Indian approaches to philosophy are very non-empirical and sort of like in the head. But like the fundamental approach to logic relies on actual evidence. In Western logic, we don't need these examples. We can come up with arbitrary implication rules. And that obviously has its benefits that we can like postulate implications that might not actually be true and then show stuff via contradiction, etc. But like this is just like a slightly different way to think about it.
So what would be examples of a Western
All like whenever you're constructing a the form of a Western argument, like propositional logic is we like of modus ponens, for example, right? We have P implies Q, we have P, and then from there we can say this implies Q. But the validity of this implication is never questioned. We never need to prove evidence for this P implies Q. Yeah, cool. Any other questions here? Okay, cool. Oh, yeah, so I sort of answered that question in the top right. But like, what do you guys think? Like, can you have formal validity? Like, is it possible to have, like, do you think this is a good thing or a bad thing? Like, from a point of view of what your model of inference allows you to do, is it a good thing that we have to have these examples, these empirical proofs in our logic, or is it bad? Oh, well, Shakti, you want to go first?
Yeah, I think it's good because then you get to like whatever deduction you make from that, you know it's like backed up. Versus like if you didn't have that empirical evidence, then you'd have to look further and figure out if like there's some validity.
Interesting. Yeah, cool. Chris?
I think that this very it like restricts like the scope of the because there are a lot of things that like, exist in the law and stuff like that. Like you can't really find people out there, but people still want to like believe yourself. I think people should be able to use like all models and that also.
Yeah, definitely.
Yeah, I agree. Like I think it is it's the best thing, right? That
Yeah, no, definitely. I think there's definitely benefits and downsides to both. When you're working with entirely empirical kind of systems, I think it makes a lot of sense to have these examples, but it sort of might restrict you from developing really kind of more arbitrary logical approaches that aren't really concerned with the material world, but more so the structure of logic itself, which is what Western logic eventually developed into. Cool. All right, so now let's take a bit of a detour. The Nyaya approaches to logic actually originally developed from rhetoric and like dialectics, and this is what happened in Greece as well, right? So Socrates was like a huge critic of the sophists, as he called them. These people who would just go out and they would make arguments without trying to seek the truth. They just wanted to sort of like profess their own kind of opinion and get people to like believe them, to convert them to their own opinion, right? So the Nyaya school originally was also very concerned with rhetoric and dialectics, and they classified types of arguments, gathas, into three main classes. So the first is vada, and this is like the discussion that we want to have. It's a logical discussion. It's based in truth, and it it's based in the pramanas, right? These epistemological premises, and it's aimed at discovering the truth. The second type is jalpa. This is sophistry, and it's framed like vada. It seems like vada. It seems like we're basing our things around epistemological. Hey, yeah, you're fine. It's based around these like, epistemological premises, and the people the arguer makes it seem like they're making a logically sound argument. However, it's not aimed at truth. It's not aimed at discovering truth. It's instead aimed at victory, jalpa. So, and then the third is vitanda. So vitanda is like the sophist isn't even trying to say anything meaningful. He's basically trying to fuck with you. It's like an internet troll. He's just like showing up and he's like, lol, Putin has only one testicle and Biden has 3. Lol. That's basically Vitanda. There's like no aim whatsoever. It's mainly just to bring down the opponent. So these are the three types of arguments. Then they also talk about a lot of fallacies. These are like informal fallacies. They don't focus on like formal fallacies. We'll talk about that in a bit. But the informal fallacies, for example, are like chala. So this is basically a strawman argument where you say someone is making claim A, but they're actually making claim B. And then there's other classes of jatis. There's other classes of fallacies called like jatis, which is like irrelevancy. So someone makes a claim about A implying B, but then you say something like, no, but A implies C, therefore we should do something else. But you're not addressing their actual main kind of critique. Then there's several fallacies of reason. These are slightly more formal, but they aren't really like formalized into like symbolic kind of relations or anything. So there's like 5 of these. A few of the interesting ones are like Savya Bhichara. Wait, is this Savya Bhichara? No, it might be Abhichara. I don't know. I might have missed the diacritic there, but this basically means like indecisive. So when you have a premise that implies multiple conclusions, that happens sometimes, right? Where you might have some P, but there's like a ton of different conclusions you could make from this. And like you don't know which one is true. You also have prakarana sama, and this is where you have a circular argument where P basically asks a question, like P implies Q, but Q then asks for further proof of like this is like if you're trying to prove P, okay, wait, no. Can anyone give me the structure of a circular argument in terms of like P and Q and R? I think begging the question is actually Sadhyasama. The border between those is kind of like hazy, I think. But like the general idea is that like you can make a
I see what the definition is. Where basically it's like when the reasoner begins with what they're trying to convey.
Yeah, exactly, right. Or maybe that's like another fallacy though, definitely. It might be this one. I might be missing a lot. But like yeah, if you take something as an axiom when you should in reality be taking steps from your premises to prove that. Yeah.
Yeah, I guess like we shouldn't be supposed to formalize it.
I asked for a formalization, but like if you have
Like saying Q, right? And Q is Q, the plus Q is Q, the Q is Q.
yeah, that's circularity. Yeah, exactly. So something like that. Cool. Yeah, so there's all of these like slightly more formalized kind of fallacies of reason that they discuss as well. And this is like in the Nyaya Sutra itself, which was written around like 200 BC, maybe even slightly earlier than that. Cool, now we're gonna get into some medieval Buddhist approaches to logic that get very intriguing. So this is called the Hetu Chakra. These are conditions for a valid Hetu. So again, you see how like this implication relation, right, is super important. And a lot of the concern in the study of inference is about like how you can make valid implications. And the Hetu Chakra is specifically interested in formalizing based on empirical evidence, how can we know that an implication is true? So basically what they say is that if we have a Hetu and it's present in a Paksha, so the smoke is on the mountain, right? The smoke is our Hetu and the Paksha is the mountain, right? This like subject, this subject we're like sort of discussing. The smoke is on the mountain, right? So that's condition 1, that's fulfilled. Condition 2, there exists a sapaksha, like a similar situation in which the Hetu is present in the sapaksha. So for example, in a kitchen, there is smoke, and in a kitchen, there's also fire. So this basically fulfills our condition 2, that there exists a subaksha that meets our hetu requirement. Then the third is the negative. So in the different cases, in the vipakshas, for example, in a lake, there is neither smoke nor fire. So that fulfills condition 3. And specifically what Dignaga, the guy who developed the Hetu Chakra, says is that when we're looking at the vipakshas, there should be universal non-occurrence. So that's why you see this existential marker on line 2, that there exists a sapaksha for the where the hetu is in the sapaksha. But for the vipaksha on line 3, you see that for all vipakshas in all the different situations, there is no hetu present in our vipaksha. Does that sort of make sense? These like 3 constraints on what makes a valid hetu. Okay, cool. So then, based on this, you can draw out like a 3 by 3 kind of chart that shows you different combinations of whether the hetu is present in in all sapakshas, all vipakshas. Sorry, like either all, none, or some of sapakshas and vipakshas, right? So plus means it's present in all of them. Minus means they're present in none of them, and plus or minus means that they're present in some of them. So based on these 3 conditions we postulated, can someone tell me where in the Hetu Chakra we'll find the valid hetu? You can think about this for a bit. We have these 3 conditions, right, that constrain what kind of like how we should, like where the hetu should be in our sapakshas and vipakshas. And then there's going to be a few cells of these that meet those criteria. Mainly criteria 2 and 3, right? Because we're assuming that the hetu is present in our function, otherwise we would be discussing it. Anyone have any thoughts? Is anyone unsure of what I'm talking about? Is this like shit? Huh? So like we can start narrowing this down, right? So
Plus as in like it exists and minus as in it exists.
Plus means the hetu is present in all the functions, and minus means they're present in none of the functions. And plus or minus means they're present in some. Yeah, Milo. So I'll yes, yeah. Cool. So can you explain your reasoning process for how you got to 2 and 8?
Also, we need to have a plus or plus minus for a function. There needs to exist as a function, so it can't be.
Right, and why can it be either plus or plus minus?
Because plus, then all of them are so for this one, right? And then plus minus, there are some positive, there's some
right, so it's basically this existential, right? Because the existential and subfunction.
Yeah. Right. And then for every, so it needs to
exactly, right? For all the vipakshas, the hetu shouldn't be present in the vipakshas. So with requirement 3 of the non-existence of hetus in all vipakshas, we can basically eliminate rows 1, or sorry, rows 1 and 3, right? Yeah, sorry, column like these 2 columns we can eliminate because we don't want to find the hetu in the vipakshas at all. It has to be minus. And then the second constraint says that we should find the hetu in at least some sapaksha so that we can eliminate 5. So we go from all of them to just 2, 5, 8 to just 2 and 8, right? And for 2 and 8, we know that either the hetu is present in some sapakshas or all sapakshas, and the hetu is not present at all in any of the vipakshas. right? So does this make sense? That like this is a mechanism for going from empirical observations on where we observe the hetu to a judgment on whether it's a valid causal implication. Does anyone have any problems with this? Does anyone think that this is like absolute bullshit and that there's like no way that like this isn't an accurate judgment of whether this is a causal relation or not? Yes.
I mean, like, this is a guarantee that, like, against the theories, right? Oh, well, I guess there could exist things outside.
Wait, explain that?
Oh, wait, never mind. So this guarantees, yeah, that it is causal, but like, it's like very
It's very what?
difficult to do this.
Yeah. Yeah, I mean, I like if we have extra time, I'll present like a counter argument to this. There's like a very simple, like there's some very simple empirical counter arguments I think that I could make. So this is something to think about for like as we look at the rest of stuff. But for Nathan, this is basically a mechanism for going from empirical observations to causal implication relations. Cool. Okay. The rest of my slides are very bare bones because I did not finish them until like an hour ago. Okay, so the Navjanya School. So we just looked at the medieval Buddhists, right? So the Hatha Chakra was developed by Dignaga, which was around like 500 AD, maybe slightly earlier than that. The Navjanya School came about 1300 AD. It's a new approach to Nyaya. So Nyaya, as we said, was founded in the late centuries BC, and it sort of developed the more early kind of primitive approaches to logic, these propositional logical forms, etc. But like what is similar to propositional logic. But when Navjanya came along, they basically developed a very highly technical language that is designed just for discussing set theoretic approaches to logic. Like when we say set theory, it means like from a Western lens, we can like analyze the work they did through set theory pretty effectively. But the main idea here is that they didn't develop symbolic formalism, but they did develop, like they didn't draw symbols like this, and like they didn't draw symbols like this, etc. Right? But like they didn't have these, but they had words that corresponded to these, and they basically had rigorous syntactic rules for manipulation of these phrases. So in a sense, they did develop formal like symbolic logic. It's just that they wrote these out. I'd say that the symbolism is useful in mathematics, not because it's like terse, like not because it allows us to write things so shortly and effectively, but rather because it gives us a means for separating syntax from semantics, right? We can now have just these strings of symbols, right? And we can manipulate them with our known syntactic rules, right? We can say if like we can say x plus 5 equals 8, right? And we don't even have to think about the meaning of this. We know that if we have a plus, we know that if we have a plus over here, we can say like -5, -5, right? This is a syntactic operation, and then that reduces to this, right? We can basically perform these very simple syntactic manipulations and come to semantic truth judgments based on that. And that's what you enable once you develop a formal language like the Navjanya did. And like in the West was done in like the 1700s and 1800s as well, with the development of like symbolic mathematics. There's a guy in ancient Greece who also had his own kind of symbolic system for math. Dionysus of Halicarnassus, that might have been the dude. Does anyone know this? Chris? Okay. Okay, so something like that. But he developed a similar kind of symbolic formalism, but it's sort of like the opposite situation where he was using these symbols, but he was only using them as shorthand. I haven't looked deeply into his stuff, but it seems like he didn't develop these like strict syntactic formalisms of like the manipulation of these symbols. They were more just like shorthand ways to write down longer kind of sentences. And the interesting thing about Navjanya is that they might have been on the verge of discovering set theoretic paradoxes like Russell's paradox. Does anyone know Russell's paradox? Nathan, do you want to explain Russell's paradox? Like the Barber paradox, like do you know the Barber paradox like version?
Barber? Oh, yeah. The barber cuts everyone's hair in the, like the hair of everyone in the town doesn't cut their own hair.
Yeah, right. Yeah.
Is Russell correct specifically about that set? Like,
Yeah.
that if one set of all sets of where would the set?
Yeah.
Be in the set or not?
Yeah. Like does the set of all sets that contain themselves contain itself? Right. And that seems very kind of like mathy, but like a great like kind of simple version of this is does the barber who cuts all the people's hair in the town cut his own hair? Right? Like does the barber, if the barber cuts everyone's hair, does the barber cut his own hair?
I think it's like if the barber cuts the hair of everyone
Who doesn't cut their own hair? Yeah, that's the most important.
So if the set contain all sets
That do not contain themselves, right? Yeah. So like if does anyone know the notation for this? Because like it's interesting. Yeah, Milo, do you?
I think it's like there exists a set S such that like S so that S is not an S is in, sorry, such that like some set X that is not in.
You want to write this? Come up here and write this.
Something very briefly once.
It's like, so you have some set S that contains like such that like some set X is not in, right?
X is in S, X is not in S.
Yeah, I tried to write that. So X is not in X, right? Because it doesn't contain itself, right? Then it's in S, is S in.
I forgot to write that.
Yeah.
Is
Oh yeah, so you would do like
right.
you would do like X such that. So S equals X such that X is not X. And then
So yeah.
Okay. Yeah. So yeah. Like there exists a set there exists a set. Yeah, I mean the set is the set of all sets that do not contain themselves, right? It contains every X such that X does not contain X. Then the question is, does S contain itself? Is S in S? So it seems like sort of jargony, and we see a lot of these sort of self manipulations, right? Like, is S in S, or is X in X is not in X, right? Like these like auto I don't know the word for this, but like where we're checking whether something is within itself. So this was a big problem for mathematics in the early 1900s and analytic philosophy in general. And sort of the solution to this, one solution was type theory, where we basically say that any set is a we instead do away with the notion of sets, and we instead replace them with types. And we basically say that like a type cannot be like can definitionally not be a term of itself, right? So if you look at like math, for example, you have like 5, which is of the type int. You have like 29, that's also an int. But it's meaningless to say is int a type of int, right? Because those are like, this is a type. You can't have a type as a term of itself. You can have a type as an element of a type universe, which is something very interesting that you can like learn more about in the type theory Stuco, I think. It's called like hype for types. But yeah, so it's like, this is like interesting stuff that happened in the early 1900s. in set theory, but it really grew out of the traditional analytic philosophy tradition in the late 1800s with Gottlob Frege. And there's a paper from like the 1970s where they basically show that there's this one Navjanya text from like the 1400s where the guy basically says like something along these lines. Like he talks about sets, the set of sets that do not contain themselves, but like he doesn't like start asking this question or something. But like he basically like there's marginal evidence that like Navjanya was like on the verge of developing like some crazy set theory stuff. And like once you find the set theory paradox, it like inevitably sets you off on like a chain of questions of like, okay, so then how do we fix this? Like how they would have basically seen, okay, this set theoretic like explanation for logic is not sufficient because it clearly has paradoxes within it. So then they would have had to search for like a different approach to defining their logical notions. And maybe you could have developed type theory and all that shit. But like that's all speculation at that point. But it is kind of interesting to see how a completely different tradition arrives at the same kind of questions. And like, does that mean that mathematics and logic are like underlying truths that we're just like observers of? Okay, cool. So skepticism and defenses, this is like skepticism of specifically logic itself. There's the Charvaka school, which we talked a bit about last week. And basically their argument with respect to logic is that just because we have seen the Hetu present in the past, right? Just because we've seen it present in the examples that we provided, right? The subaksha and vibhaksha, that doesn't mean that this relation is going to hold in the future. How can we just go from this correlation, which we've observed, and then assume some kind of causal implication? That's their question. And one of the responses, there's a lot more sophisticated responses. But like one of the responses is like, how can you make this logical argument without admitting the validity of logic in the first place, right? Like in order to make a logical argument about identifying causality and making kind of like there's an implicatory there's like an implicatory structure of this argument, right? Because it's saying it's basically saying that like Hetu, observation of a valid Hetu in the past does not imply Hetu implies like P, whatever, like whatever like proposition we want. This is the wrong notation, but like they're basically saying something along these lines. And one of the responses is like, how can you talk about these implications or non-implication without admitting the validity of logical implication in the first place? So that's one kind of interesting dialogue, like line of argument in meta logic, I guess. But what do you guys think about this? How can we identify causation from correlation? Obviously, this is a long-standing question. Does causation even exist? How can we go from these things that we observe in the real world, right? These like data points, and infer a causal relation, identify this line from it. How do we do that? Is it possible? Chris?
So you're talking about things like scientists find that like some specifically like I think it's fair that for them to point to these like say like, oh, this is the causing sense. Again, then we see that like you can always observe like these elements with cancer, and then you like anyone the cancer out there like basically assume, or I guess it's justified in. So yeah, I guess it kind of makes that. But even though like, people always say, oh, the correlation doesn't necessarily cover stuff like that, and they want us to not want them to think about that stuff, like they're still considering that. So I think as long as they're reasonable about it,
yeah, I guess like that's like what the traditional argument here is, right? That if we observe If we observe it in the subluxury, we don't observe it in the vipluxury, then we can imply some causal relation. I guess like what a Charvaka would say is like, okay, sure, you like observed a bunch of these instances, but like, what if there's like other like yellow aliens that are doing it in these other cancer cells? Like you might have never observed them. Like, how do you know? Any other thoughts, Milo?
Well, I mean, we're just talking about method of this valid, right? I mean, like you could see, like I could observe, like I don't know, some like random thing happen once, and by maybe two things I've never seen it happen before. Like, then yeah, this is true, right? This implies this when it could like very obviously not.
Exactly right. I think it's very hard to understand causality when we're looking just at data, and it's sort of the same thing. This is still a huge struggle in like modern machine learning, right? You have, for example, we have very good accounts. We have like GPT-3, for example. So GPT-3 is this huge language model, and it's trained on billions of text, like tokens of text. And it's very good at generating natural language text. You can feed it in a prompt, and it'll finish your sentence, and it will sound just like another human wrote it, like some expert human, maybe even a professor. It can write like whole news articles that sound about right. But like causally, it doesn't seem to have like an internal model for the structure of language, right? The way we structure language is like these syntax trees, right? Like you can have, so like you have a noun phrase and a verb phrase. Like this is just like one account, right? And then you have noun, he eats food, right? This is like a syntactic structure that we could say this is like the causal structure of language, right? Like this is what, like these underlying syntactic structures and the relationship between words, the type of meaning that we're trying to express, this results in this surface utterance. And that's what we hear, that's what we comprehend. But GPT-3 basically just has a huge number of parameters, right? It has a ton of numbers that allow it to approximate the patterns of words it sees in the world, right? It sees like a shitload of words, and it's like, what are the patterns I can pick out here? And it converges upon a correlative measure, a correlative model that is really good at generating these kind of patterns. But does that mean it understands the causal structure of language, right? Like this underlying relationship? I don't know. Nathan, do you have those?
Are you talking like the sophisticated form of Markov chain?
It is like you can think of it as like a really fancy Markov chain. The way like GPT-3 and language models work in general is that it's like the probability of a token Tn given context T0 Tn minus 1. And then it gives you a probability distribution over the next tokens. Yeah, Mari?
In all the other end, like programs like this that can access the text language will evolve, like for instance, the density evolution of the suffix I think maybe that would show some sort of.
Yeah, like the causality, like causal structures and like historical language change. My friend in the LTI, like Language Technologies Institute, he works in like David Mortensen's lab, and they work on language evolution actually. So they have these computational models of how languages change over time. They have agents that use these languages, these constructed languages, and they observe how the way they speak, what the grammatical structure is, what the phonological structure is, and how those evolve over time. And one of the interesting things they find is this, okay, I won't go into that, but like there's like this very cool statistical model that you can use called the Chinese table argument. It's like a specific instantiation of a specific Do you know this? No, not Cyril's Chinese room. There's like the Chinese tables in a Chinese restaurant. It's basically a way for approximating how like things coalesce together, right? If you have like a bunch of tables, you start assigning like people at each table, but then like statistically, like you like start discarding tables, and then like you end up such that like you have a bunch of things like clustered upon one table, and like something like this is like turns out to be a good model of like explaining how sound systems emerge in language. Yeah, in terms of like language evolution, yeah, there's some cool statistical model. But then again, the question is like, if we were using this to model evolution in real world languages, would we just be describing our observations, right? These like simple correlations, or would these actually provide us with insight into the causal relations behind what causes these sounds to coalesce, right? How do we know whether we're just describing some surface level phenomenon with some like completely arbitrary statistical model, or if we're converging upon the underlying relationship between things? Okay. Any other thoughts here? Causation versus correlation. Okay. So we like a couple more slides left. The first, so this is another kind of interesting thing in Buddhist logic. I think this is also Dignaga, who developed the Hatha Chakra as well. This is Chatashkoti. Actually, this even predates Dignaga. So apparently, there's a story that like the Buddha himself was asked a question like have you always been alive or something, or like yeah, like have you always been alive? And he responds by saying, I have always been alive. I have not always been alive. I have been always alive, and I've never been always alive. And I have never been always alive, nor have I been never alive. Some crazy shit like this. It's like very mystic and weird and everything. But then what do these people do? They like formalize it into a logical system, of course. So basically they develop this logical system where you take as axioms these seemingly contradictory statements. A proposition can be true, it can be not true, it can be true and not true, or it can be not true or not true. Like that, yeah, not true or not true. Does that make sense? Like, yeah.
Wait, is that
This decomposes actually by Demorgans Law into true and not true. Like it decomposes into three. Yeah. I wonder if they knew that. I wonder if they knew Demorgans Law between 3 and 4.
does it hold?
Huh? Yeah, it's very straightforward. I mean,
No longer excluded.
oh, it might not. It might not. I'd have to think about that for a bit.
Wait, so the law of exclusion rule says that it can be both, or that it can be not.
The law of excluded middle says that either.
When there's no law of excluded middle, that's saying that there can be both, or that it can't be both. Like,
So wait, the law of excluded middle says that it can be true or not true. No law of excluded middle means that it can be either. It can be either both or neither. Yeah, either becomes a possibility. Does it make sense?
so I guess it wouldn't be, right? Then I guess law of Demorgans Law would be.
Why?
Because if we take that to be a statement, right? if we
Which?
take P or not P to be a statement, then if we say not that statement, that doesn't imply like. Yeah, and that would.
Wait, can you explain this?
Necessarily that P is true, just because, like. Wait, hold on.
Wait, so P or non-P?
Wait, yeah, because P or not P could be true even if P and not P is not true, right? Because like one of like the two guys like I can think of an example. Like I guess like not P could be false and P could be false. 3 false, 4 true. Yeah, so Demorgans Law. Say P and not P are both false.
Uh-huh.
3.
Wait, so like P is false?
P is false and not P is false. So there is no law of exclusion.
Oh, I see what you mean.
Yeah,
Okay,
then
so
Demorgans Law doesn't.
I see. Okay. So we basically say that P is false and not P is false. No. Oh yeah. So wait, no. But then that's not true, right? 3 is not true. 3 no longer holds.
Yeah, exactly. So.
So that's why you need to have 2 of them. Oh, okay. That makes sense. Does everyone get this? I feel like not everyone gets this because I definitely did not understand it until like 10 seconds ago.
So if we're saying, basically, if we're saying that P and not P are like not mutually exclusive, something can be both P and not P, right? Or something can be both not true and not false, right? Then 3, let's say both P is false and not P is false. They're both false.
Yeah, which is weird to wrap your head around because like supposedly P should always be the same value, right? Like P itself should always be true. But we're allowed to say that like not P is also false because the not operator doesn't behave the way we'd expect it to. Yeah, continue.
Yeah, but then like P and not P is false and false, right?
Yeah.
And then 4 is false or false, right? Definitely not that.
Not, yeah, it becomes true.
We can actually not. Oh yeah. So
Yeah, I mean the function of the not operator becomes kind of confusing once you throw away the law of the excluded middle.
I
Right?
don't think not false is true, right?
Yeah. Not false doesn't imply true. That's the entire thing with law of excluded middle.
So 3 would be false, and then 4 would be not false. So
Yeah. I mean, your example where we hold P and not P as false, it shows that Demorgans Law is not true if we throw away law of excluded middle because 3 becomes false and 4 becomes true, and that means that we can't decompose 4 into 3, right? That's the general structure we already. Yeah, well, that makes sense. Yeah.
Is there an example of something that's where the law of exclusion is not true?
I in natural language I feel like it shows up a lot, right? It's hazy, but like the Buddha, for example, says, I have always lived forever, and I have never always lived forever. Like I've never lived. Right, like that's the whole thing. Like, oh no, wow, it's like blows my mind. Oh no, but like it's not like this is not bullshit. Partly because like constructive and intuitionistic logic is like a thing in the West where they also throw away the law of the excluded middle, and that's like what they do in the philosophy department here. Homotopy type theory. They're basically developing. They're part of this broader type theory approach to foundations of mathematics, where you throw away the law of the excluded middle. And use types instead of sets as your foundation, and then you see like what you can do. And it turns out the type theory is also really great because you can like computationally formalize it much easier. So that's what they're doing there. Cool. So definitely a lot of stuff to think about here. Definitely a topic for a final project. Diving deeper into this if you guys are interested. Drawing like parallels maybe to constructive logic and stuff. Cool. Then this one's even more hand wavy. Jaina 7-valued logic. You can see how like the Gnostica schools, like the heterodox schools in Indian philosophy, are always very they're very strongly heterodox, right? Like for the Charvakas, for example, we looked at, they're always like skeptics. They're always like, how can you know it's a causal relation? Like, how do you know, bro? Like it could just like not hold tomorrow. Like the sun could disappear. Like how do you know that's true? And then like the Buddhists are like, bro, the Buddha's always lived forever and he's never lived forever, bro. You just need to understand, bro. Like your brain just isn't big enough to comprehend it, dude. And then the Jainas are like, actually, like true and false are like not real. There's actually 7 of them. Like Boolean logic does not exist. You need to expand your mind to encompass all 7 possibilities. And the 7 possibilities are conditionally P, or actually, let me not say P conditionally because like they say conditionally on all of them. Okay, so P, not P, P and not P. P is inexpressible. Yeah, P question mark P. And then 5 is P, P. And then 6 is not P, P. And then the last one is like 3 at the same time. It's P, not P, P. So it's like it. I guess the main thing here is that it adds this additional operator, which we can call question mark. So listen up. It's P, not P, P and not P, P and P, P, negative P and P, and then oh yeah, and just P, and then also 3 P and not P and P. Okay.
Okay, what does inexpressible actually mean in this context?
You're gonna have to read some Jano 7 value logic to understand. That's all I can say. I guess, yeah, I don't know. To me, like it's sort of redundant once you throw away law of excluded middle, right? Because if you can say both, if you can say P and not P, then like what does that mean to be different from P being inexpressible? I'm not sure. I haven't looked deep in.
Question mark is that space in between of what P is if something is not P and not P.
Right, but I would say then that like,
Oh yeah, but then it wouldn't make sense.
right, like I would say something like this,
Exactly.
but like,
Clearly not true.
yeah,
I feel like it's more intuitive to think of it as like the 4 from the earlier, like
the Chaturshruti.
because if it's inexpressible, you can't say it's either true or false.
Exactly, right.
I see.
Right. I mean, like that's exactly what I'm saying too, right? That yeah, like if we're saying it's both true and not true, that means it's like inexpressible, right? Like what does inexpressibility hold for us? Like the specific word when they say inexpressible is avaktavyam, which literally means non-wordable, like avaktavyam. So like this root means to like speak. This is like the negation. So like so like let's look over here first. Tavya means like to be spoken, like to be. It's like a gerundial suffix. So not to be spoken of, I guess is the best way to think about this. Yeah.
It feels odd though that they would like assign, let's say it is like not P or not P, right? It feels odd that they would like stop at 7. Because then it would make sense for them to have a operator that is not P or not P or P.
Where are you getting the ors from? I think all of these
I mean, if we say like we can think about P inexpressible, meaning it's not P and it's not P, right? There should theoretically be a state where it is not P, it is not P, and it's not inexpressible, right? And that would be another truth state.
Oh.
Right? Like it feels weird that if like P being inexpressible means P not P, that they only have 7.
Oh no, this is not true. This is what
I'm saying the other one, like where if it's not P, nor is it not, nor is it P.
It's not P nor it is. Wait, you're saying it's P and not P?
Number 4 on this thing, if we express
Oh, from the previous list?
as 4, right? With those that you just said, right?
If we express which is number 4?
P being inexpressible.
Uh-huh.
P is number 4, right?
Uh-huh.
It feels weird, like it feels weird that we only have 7. Like they would say the law of exclusion rules, like it feels like they would have like there would be like an infinite.
Yeah, I guess like when you start conjuncting these, like this is like my problem with this as well, right? Like once you have this conjunction operator, like what is stopping you from like adding more to this, right? Like
That's what I'm saying. Like why is there only 7? Like why is that not a true state?
yeah. Yeah, I don't know. I think I haven't looked into it deeply enough. again, like a good final project topic. Maybe it also links into like fuzzy logic. Like this is like fuzzy logic is an approach to logic from like the 1960s or 70s, I think, where like instead of having like Boolean 0 and 1, you have like 0 up to 1, right? So you can quantify the truth value of a statement with a floating point, like a real number. Cool. Any other questions on this? All right, I think we're almost done. Yeah, so then there's other types of inference that they talk about. So we've mostly been talking about anumana. There's also upamana, analogy. So this is like the traditional example is like someone has never seen an ox. They've only seen like they've only seen like cows or something. So then like the person describes to them, oh, a bull is, or like an ox is like a cow, except it's like bigger, something like that. I don't know what an ox actually is, but that would be like analogy, right? Like you're drawing a relation from one thing to another, and it's slightly different from inference. Actually, it's completely different in structure from inference in the sense that we don't have this this like implicature rule, right? There's no like causality that we're talking about. Orthopathy is like a more complicated relation. It's usually translated as presumption, but honestly, I think a better way to think about this is to think about this as a rule for performing deductive inference, like, right? Anumana is deductive inference, and then orthopathy as a mechanism for inductive inference. So deduction is when we have a causal rule, right? Something that we assume to be true, and then we make deductions about the state of the world. And induction sort of goes the other way around, that we that we look at the state of the world and then we make causal inferences about them. There is sort of a small inductive step in the process of using the examples, right? The vipaksha and subpaksha to construct this causal inference. But the specific nature of orthopathy is slightly different in that like it focuses entirely on constructing these like generalized principles that we can apply elsewhere. And that sort of seems to me sort of like induction maybe. And then anupalabdhi is non-apprehension. So we can like perceive stuff, right? I can perceive that there is a chair here, but we can also have like non-perception. Like for example, I don't perceive that there's a tiger here. So certain schools of philosophy will say that that's like a different form of perception, almost like a different form of knowledge than just regular pratyaksha, regular perception, because I'm not perceiving the tiger, I'm perceiving the non-existence, the non-apprehension. So they posit this alternative type of inference, anupalabdhi. Cool. Any questions on these other pramanas? Okay. Cool. All right. Midterm assessment. Should I continue recording or should I stop recording? It's up to you guys. Okay. Cool. Okay. Wait, did I stop? Oh no, I have not.